Okay, the idea is to use this approximation that I'm going to, to tell you is when x is very, very small compared to the 1, when this x is very, very small compared to the 1, you can approximate 1 plus something very, very small to the power of m, like 1 plus mx. But this is when x is very, very small compared to the 1. So we are talking of approximation like this 1 plus 10 to the power minus 3, everything to the power of 5. What will be the amount of this? This will be 1 plus 0.01. So it will be 1.001 multiply 5 times 1.001 by 1.001 by 1.001. This is approximately, this is an approximation, is 1 plus 5 times the m, 1 plus 5 times the m by the x, by 10 to the minus 3. If you calculate it, if you use your calculators, you will see that this is approximately 1 plus 5 times 10 to the minus 3 is 5 by 0.01 is 0.05 will be 1.005. So you can make the calculation in your computer. You can see that this approximation is working, and we'll see why it's working. So if you do this example, for example, it will be 1 plus m minus 3.5 by dx. But if you do this example, for example, this when the power is if you do this example, for example, when the it looks like the difference, not like the sum, but is 1 minus, you can always put it in this way, and this will be minus 1 minus 3.5 by what? By what? By what? Now, 1 minus 3.5 multiplied by the x. So this with the minus money will be positive, so you can work with this approximation always. But the x, remember, should be very small compared to the 1, otherwise this approximation will not work. And the idea of this approximation is take this equation, expand this equation in a Taylor series around the x equals 0. If you expand this equation around the x equals 0, if you remember, the equation will be the expansion of the Taylor series of any function around the 0 will be f of 0 plus the first derivative evaluated at the point x0 plus the second derivative evaluated at the point 0 by x squared. It will be a polynomial. It's a polynomial in x, x squared, x cubed, x4, x and n. So points here, okay. There are points here, sorry. So it will be f of x. If you do this for this function, you will find that the first two terms will be 1 plus mx, and there is another term that I have depreciated because it will contain the power x squared. That will be when x is very, very small. This I can depreciate all the other terms. So you can try to solve this problem, to find this expansion series of this function, and to prove that when x is very, very small compared to 1, 1 plus x to the power of m is the first two terms is 1 plus mx. You can prove it.